right, so we're just going to go through the rest of the word problems, and then when you're done watching, you just sign off that you viewed it, and then that'll count for the attendance for the day. So it says a candidate for a job is given the following salary options. Starting salary of $75,000 with a $2,500 increase each year. A salary based upon the formula 48,000 times the natural log of x plus 1. Which option will give him the higher amount of money during his 35th year? How much will she be earning at that point? All right. So basically, all right, the first, let's cancel. All right, so we're going to draw. Get the old, okay. So if they're increasing the same each year, it's going to be linear. So that would be represented by 75,000, the starting salary, plus 2,500 N, where N is the number of years. All right, 35th year makes N 35. So I'm going to just substitute 35 for N. I go to my calculator and I do 75,000 plus 2,500 times 35. And I get 162,500. Seems like a good amount of money. All right, but after 35 years, people tend to deserve it. Now let's look at the natural log of the next one, where it says a salary based upon the formula 48,000 times the natural log of x plus 1. So now we're going to do 48,000 natural log of 35 plus 1 is 36. Again, the plus 1 gets rid of the 0. All right. So go back to my calculator and I do 48,000. All right, times the natural log of 36. And I get 172,008.91. And then that's how much she'll be earning, because that's more money. So she would definitely take the one modeled by the natural log. All right, next one. Fant has a business plan where the number of franchises he owns can be modeled with the function f of t equals 45 natural log of t plus 1, where t is the number of years since he started. Under his plan, how many franchises will he have in the year 2036? Well, assuming we're in the year 2021, all right, t would then be 15, because we're talking about 15 years from now. So 45 natural log of 15 plus 1. Now keep in mind the 45 represents the initial, because if we plugged in 0, 0 plus 1 would be 1, and the natural log of 1 is 0. But for this, all right, what it says under this plan, how many franchises we have in the year 2036? So we go to our calculator and we do 45 natural log of 16, and we get 124 franchises. All right. So basically, he's looking to almost triple the number of franchises he has. Now, part B says, in 40 years when he retires, what will be the mean increase in the number of franchises per year since he started in 2019? Well, let's assume he's starting in 2019. All right. So that would be 40. So 40 years. So now we would do 45 natural log of 40 plus 1. All right. All right. So now we're going to look at, oh boy. All right. Now we're going to look at 45 natural log of 40 plus 1, which is obviously 41. So 45 natural log of 41 means 167 franchises. All right. So obviously things are going to slow down a little bit. So to get the mean increase in the number of franchises, we look at how many franchises would start. Now, if I plugged in 0, all right, 0 plus 1 is 1. The natural log of 1 is 0. All right. And then that would be 0 franchises. So now, okay, that means he will have gained 167 franchises in 40 years. I do 167 divided by 40. 167 divided by 40. and I get approximately 4.175. All right, next one, and I believe it's the last one. The number of students at a dance can be modeled by the equation d of t equals 700 minus 142 log t plus 3, where t is the number of minutes since the dance started. Determine the number of students still at the dance after 3 hours. Again, the time is in minutes, and this is in hours, so you got to convert. 3 times 60 would be 180. So 700 minus 142 log of, all right, 183. I go back to my calculator and I do 700 minus 142 log of 183. And I get 378 students. All right. So basically, when you're doing these for the quiz, okay, basically all you're doing is evaluating. We'll do the equation solving ones later. All right. So, like we said, just sign off that you watched it and you're good for the day. All right. Enjoy the snow, everybody. Bye.